Design Assistant showcasing how Breadth and Terminal Slot Optimizer Copilot is built using Microsoft Plan Designer. This solution demonstrates how AI supports marine and terminal planning by proactively detecting breadth conflicts and recommending optimized slot arrangements. This breadth and terminal slot optimizer follows an AI first design approach. Instead of planners manually spotting conflicts on complex timelines and intelligence is embedded directly into the planning workflow. Copilot continuously evaluates, schedules, predicts congestion, and suggests improvements before delays occur. This design begins with clearly defined terminal planning and marine operational requirements. These requirements are entered into the plan designer, which generates a structured covering process, components, roles, and responsibilities. The planner acts as the architectural backbone, ensuring Copilot automation and scheduling interfaces operate in harmony. So now let's come to the roles and responsibilities. We have Marine Terminal Planner as a user, an Operation Manager as the other user, and the Breadth Supervisor. These are three different users my plan design has created for me, and it has defined the clear responsibilities for each role. This looks good for me, so let us go ahead and create it. Once the roles are defined, then it's time for us to create the key process. The plan designer is going to help us create the different process which are required for this purpose. As you can see, it has created multiple process. Breadth schedule intake and visualization is the first process where the outline is defined. This process covers the intake of vessel schedules, breadth assignments, and the visualization of terminal slot timelines. It ensures all planned vessel movements and accurately captured and presented for situational awareness and planning, which is this process. Let us take a look at it. So as you can see, the system updates scheduling data captures and then system generates unified timeline, view of breadth and schedule, mirror and terminal planner receives the timeline. Depending on the decision that is being made, the intake is being provided. Now let's see what are the other process we have. The next process that we have is my role. The first process is there, conflict detection and congestion analysis. Copilot continuously scans the timeline to identify overlapping breadth assignments, tight turnaround windows, and potential congestion points are detected. So let's see how the analysis process looks like. Yeah, conflicts and congestions are used as a decision maker here. And then system generates AI driven alerts. System presents terminal performance. Marine terminal planner receives AI driven alert. And then system presents a terminal performance metrics. So this is how the conflict detection and congestion analysis has been done. The next process is AI optimization and slot recommendation. AI slot optimization recommendation. What this process does is when a conflicts arise, Copilot proposes alternative breadth or slot arrangements. Each recommendation include a clear explanation of how it reduces congestion, improves safety buffers, or optimizes terminal throughput. So generates alternative breadth and slot arrangement. Copilot provides clear explanation for each recommendation. Marine Terminal Planner evaluates Copilot recommendation and makes a decision on it. Copilot updates terminal schedule. The next process is approval and schedule updates. This process encompasses ongoing monitoring of terminal schedules, analysis of historical congestion, and waiting patterns. It also does continuous learning to enhance further breadth and slot planning. Let's see how this process looks like. Planner generated task support approval workflows without manual rework. Initiates approval workflow. System creates automated approval task for breadth. Supervisor reviews or either approves or rejects the request. And that is based on the supervisor's confirmation, the respective tasks are performed. The last and final process that we have here is monitoring and continuous optimization. This process encompasses ongoing monitoring and terminal schedule analysis of historical congestion and waiting pattern and continuous learning to enhance future breadth and slot planning. Let's see the process. As the operation progresses, Copilot monitors the actual breadth usage and outcome. These insight are fed into the system again for continuous improving further slots and recommendation. Once the Copilot identifies the scheduling conflict, backend automation triggers notification, creates rescheduling tasks, and refreshes planning timelines automatically. System monitors and terminal schedule in real time, collects and analyzes historical congestion, manager analyzes historical congestion, and then the system updates the learning models to enhance further. So this is how the process is defined. So all the process looks good for me. Let me go ahead and confirm this. Once I confirm these process outline, my data model is now getting created. Yeah, the tables are, as you can see, vessel breadth, terminal slot, schedule, conflict alert, optimization recommendation, approval task, which is good enough for me for now. So let me confirm that as well. What happens after the tables are confirmed is my technological stack is being built. What tool can I build? What apps that can be built for this? All the recommendations are here. Let's go over the recommendation. So, breadth slot optimizer copilot. So, this is an agent which will help the planners to detect conflict, propose optimized slot arrangements, and explain scheduling trade offs for marine terminals. The next is an Canvas application or timeline for app planners and supervisors to review the schedules, record vessel events, view breadth assignments in real time. And then we can have a dashboard, notification workflows there, scheduling approval assistant agent is there. All of these looks good to me. So let me confirm it first. So once I confirm, the underlying data model and the apps are ready to get deployed. So tables will get created first, and then we can select whichever app we are going to create. So as soon as I click on the plus sign here, Previously, we saw the breadth slot optimizer copilot, how it is designed, what are the data model, what are the apps we are planning to create. Now, I will show you the output of the apps. Right now, we are inside a Canvas app, breadth timeline visualizer. So I have three screens here. One is vessel, breadth, and time slots. The technicians can input the entries into the system using this application, or the monitor reviewer can view the data from here. So as you can see, the names of the vessel and the latitude and longitude, all those details are given. Similarly, I have a breadth screen and a terminal slot screen. This is about the breadth timeline visualizer. Let me now show you the agent that we have created for this purpose. We have breadth and slot optimizer copilot. So I'm asking this agent to check if all the vessels are on time. As soon as I asked, it went and checked, and it said list the vessel's name, saying what is the current status: completed, planned, in progress, delayed, and then planned. So what is this inferring from the data? It is saying one vessel, Odyssey, is currently delayed. Therefore, not all vessels are on schedule. This delay may indicate a potential scheduling conflict or risk of congestion, especially if Odyssey's berth or slot overlaps with another planned or in progress vessel. It is recommended to review the berth and time terminal slot tables to identify the operational bottlenecks and consider AI driven alerts. For real time conflict detection. So, I asked a question saying if it is on time, it identified that one of the vessel is not on time, and it is giving the possible reason, and it is also giving the recommendation what can be done, and it has grounded the data with the reference data we have given it. Again, I'm asking to summarize what is slot optimizer. So it gives what is slot optimizer, and the main focus are: slot optimizer is designed to enhance terminal slot and breadth arrangements with a focus on improving both efficiency and safety. Its main focus include generating recommendations such as swapping or shifting slots, delaying or advancing schedules. So this explains the process. These functionalities are explained mainly to feed back into the loop so that the model get trained better based on the input it has. It is given certain examples. Similarly, I'm asking one more question. So it can propose a optimized slot also because there's a delay in the vessel. It might see an overlap. So I'm asking propose a new slot. Let's see what it does. So based on the current vessel schedules and slot optimizer recommendation, the following slot adjustments are proposed to enhance operational efficiency. So it's saying move the slot for this vessel. It has given the vessel name and then saying like how to move from slot 1 to slot 2 at berth A, and then the gain of it is all it is giving, and it is giving the reasoning behind the decision that it had made so that it supports the recommendation, and somebody who evaluates it can use this and verify if the recommendations are correct or not. That is it for breadth and